Tomorrow we'll have the quiz, and then after the quiz, though, I have a short lesson to teach you, but you don't have necessarily any homework on that. It'll be easy tomorrow. All right, so the first section on the quiz tomorrow is about interval notation. And you will have 2 questions on this. So let me just give you like some examples. How do you write x is less than or equal to 3 in interval notation? I have a question just like this. What would you write? What's the lowest value that x could be?
Negative.
What's the highest value that x could be? 3. Bracket, parentheses, both, neither, what? Parentheses, bracket. That's all you have to do. X is less than or equal to 1, or x is greater than 2. How do I write just this one? What is the lowest value that x could be if x was less than or equal to 1? Negative infinity to where? 1, bracket, parentheses, or actually parenthesis bracket. Or you would write unite. Then how do you write x is greater than 2? What would be the lowest value that x could be?
2.
To where?
Infinity.
There you go. And then they both are non-included. So you'll have 2 questions like that. Can you handle that? Of course you can. So that's the first part of the quiz. Second part of your quiz. Is it a function or is it not a function? Okay. And you'll have 2 problems like this. And I can give you a picture, or I can give you an equation. And you just have to know, use all your little tricks in your brain. I could also give you a table of values. You need to know whether it's a function or not a function. So is this a function or not a function? Tell me why. Why no? There you go. It is not a function because it fails the vertical line test. Anybody know if this one is a function or not a function?
Probably. No.
It is a circle. Are circles functions or not functions? Not functions. But if you were to remember, you could solve this for y. Take a square root. When you take a square root, you have plus or minus square root of 9 minus x squared, which means this plus or minus means you are assigning 2 values for y to your x input. So meaning if I put a 1 in here, I would get out positive root 8. And then if I put a 1 in, I could have gotten negative root 8. Well, which one is it? Well, that means it's not a function because you're getting, your x's are repeating with 2 different y's. So this is not a function. Okay? So you'll have 2 questions like that. Third thing, evaluate a function. There'll be 3 of these. I will give you a function like h of x equals x squared plus 3x minus 7. And then I'll say, I'll keep it really easy. I'll probably do like h of 1, h of w squared, and then h of c plus 3. Okay? So really, really easy. Evaluate means just plug it in, plug it in. Everywhere you see an x, put a 1. 1 squared, 3 times 1, minus 7, and tell me what that gets to be. Which I don't know what it is. 1, 4, negative 3? But with this one, you do have to work this all the way out to something that's simplified. So everywhere you see an x, you're going to put in c plus 3. Plus 3 times c plus 3 minus 7. I do not want you to stop here. You have to work it all the way. You have to simplify it. So what do you have to do here?
C squared plus 6c plus 9.
Right. You have to FOIL, and get c squared plus 6c plus 9. You then get 3c plus 9 minus 7. And then, again, still clean it up for me. C squared plus, 9c plus 11? Yeah. So that would be like, quote unquote, your hardest evaluate the function. Okay. Fourth thing you have to know, there's a lot of information on this. That's why I'm being really nice and giving you like a little review guide. There's 11 different things we learned. That's why I'm doing 11 examples. The domain of a function. And domain of a function when I give you an equation, not necessarily the graph. Okay, you could look at the graph, but let me give you, there's 2 examples. I'm going to give you 2 right now. I'm going to do it like this. And if you're looking your notes, I've gone over these before in your notes, but domain of a function, what can your x's be? Well, your x's can be whatever they want to be, but when you're given a fraction, we have restrictions where? What can the bottom not be? 0. So what I do is going to seem weird to you. It seems the opposite. Well, you just told me it can't be 0. I'm actually going to set it equal to 0. And I'm going to solve it. So I'm going to factor out an x. I'm going to be left with x plus 11. And I'm going to find out what my values for x are. What are my 2 values here for x? 0 and negative 11. And so then you would go like this. Because that's what x cannot be. And your domain would be, and you can write this, all reals except 0 or negative 11. That's what your domain can be. Your domain can be whatever it wants, but please don't let it be 0 and please don't let it be negative 11. Because if you had 0, you would get 0 in the bottom. If you had negative 11, you get a 0 in the bottom, and it can't be that. Now, there was a way to write this in interval notation. Interval notation would be like, again, your smallest number. If I'm talking about everything on the axis, I'm talking about negative infinity all the way up to where? What would be my next lowest point? Negative 11. United with negative 11 to 0, united with 0 to infinity. That's how you would actually appropriately say that in interval notation. But you can write this for me for right now. Just write all reals except for these 2, Mrs. Sena. All right, what if I give you a square root then? What do you have to remember? What can underneath not be? It can't be negative. So it has to be, so this is where you do the following. Whatever's under here, you make it greater than or equal to 0. I'm allowed to equal 0 under a square root? Yeah, you can. You can take the square root of 0. Your calculator will tell you it's 0. So whatever's under here, put greater than or equal to 0. Solve it just like you normally would. X is greater than 7/3. Write that for me in the correct interval notation, though. That one you should know how to write in correct notation. How would that be? X is greater than or equal to 7/3. What's the lowest that you could be? 7/3. What's the highest then you can be? There you go. Okay. So domain, that I'm just going to tell you what you need to do. In order to find a y-intercept, you do what? Do you remember? Plug what? X and make it 0. Okay. So plug 0 in for x. You just know how to do that. I'm not going over them one like that. But I am going to go over this one. Find f of 2 given f of x equals x squared plus 5, comma, x is less than 1, x minus 7, x is greater than or equal to 1. So I'm giving you an evaluate the piecewise. That's what it is. And I'm actually giving you, I think, 2 of these. Well, it'll be this, let me say that. It's the same piece. It's the same piece, but I'm just going to give you 2 different numbers. It's the same piecewise. So if I said, okay, find the f of 2, find the function for 2. Which piece am I really looking at?
The bottom one.
Why the bottom one?
Because 2 is greater than 1.
2 is greater than 1. That's your domain right there. So you don't even worry your little heart about that guy. You just plug 2 into the bottom one. F of 2 would be 2 minus 7, which is -5. Done. That's it. If I give you another number like find f of 100, you need to know which piece. You don't plug them into both. Do not give me two answers. It's one answer. All right? Something easy like that. I used little Post-it notes, and I was like, okay, domain is how wide is your graph getting? Well, with that dot, it means it's stopping right here. Would you agree? Wide. How wide is this getting? But with that arrow, even though it looks like the arrow is going up and it kind of looks like it's stopping here, that arrow will creep out ever so slightly, which means my x-axis will expand the whole entire time, correct? So my domain would be, what's the smallest value on the x that I could be? -3 to where on the x am I going? I'm going toward infinity. There would be a bracket around -3 because it is closed. If I had a hole there, I'd put a parenthesis. Okay? My range, on the other hand, is how tall is this picture getting? How tall? Okay? Well, it looks like there's no picture from here. And then it's going up and up and up, and then that arrow means it keeps going up, right? Well, this time you say range according to the y. I still have students always giving me x values, but range is always on this axis, okay? So where is the range starting at? It's starting at -4. And then it's going up to infinity. Okay? And that would be how you find domain and range. So think about it like a little window here, a little window up there. How wide are you getting? How tall are you getting? All right, we're getting down to the end. 8, 9, 10, and 11, and I'll be done. Thanks, Mrs. Seta, for giving us this outline study guide. You're welcome. You're welcome. But oh well. And again, looking at pictures, it should be easier for you. You don't have to plug in your calculator. The pictures will do it for you. What symmetry? I should actually say x, y axis origin or neither, because I think one of these has neither. Oh, well, here we go. What symmetry does this one? Is it flipping over the y with the same picture? Flipping over the x? Can I move it upside down and it looks exactly the same? No, that just shifted up. Here it was on the bottom, so this is actually neither. What symmetry is this one? It's the x-axis. Again, if you fold it right here, this would be a mirror image of this one. And then this one, x-axis. This one right here, I'm sorry, it's not perfect, but I intended it to be y-axis. Can you handle that? Of course you can. Woo, we're going, we're moving. Even, odd, or neither. Even, odd, or neither. F of x equals x cubed minus 6x plus 7. Without putting in your calculator, can you tell me, oh, by the way, you'll have 3 of these. 3. Without putting in your calculator, can you tell me? Even, odd, or neither? Let's see. The trick I taught you was, if it's a polynomial, you look at the exponents of x. That is cubed, which is odd. What's this exponent? 1. Which is odd. What's this exponent?
0.
0, which is even. Can't be odd and even at the same time for this one. So this is neither. You can check it in your calculator and see if I'm right, but that's the little trick. Okay? All right, last 2. Concerning the continuity, I'm not going to do one right now for you. You will have 2 of them to determine if you're continuity. Now, what I mean is I'm going to give you a function. I'm going to give you the point. And I'm going to ask you, is it continuous at that point? And you will do 3 steps for me if you have to. What's the first step you do?
Plug it in.
Plug it in, plug it in. Plug it in. If it passes that test, meaning you don't have a 0 in the bottom or you're not taking the square root of a negative, if it passes that test, what's the second step you do?
Make a table.
You need to make a table. And I really want you to see that table on your paper tomorrow, on your quiz. That table, when you make your table, your y values, when you head toward, I don't know, let's say x is 2, you need your y values to head toward the same number, 5 or 7. They both need, those numbers need to get as close to 5 as it can, or whatever number it's getting. If it passes that test, the third test says, okay, then make sure that this number from 2 is the same as what you got out in number 1. Make sure that number 1 equals number 2. Whatever you got in number 1 for your y is the same y you got in number 2. Whatever you got for your y is the same y, okay? So if you don't know how to do those, you're going to have some questions on homework tonight that'll make you go through the continuity test again. And then the last thing we learned, like I showed you, this has a lot of information. End behavior. End behavior. There'll be 2 of these questions. And I will give you a beautiful picture. I'll do like that. Okay? Does that look crazy enough for you? It doesn't matter about this. No, it means nothing. You look at your ends. Okay? As this is what you're going to write. As x goes to negative infinity, what are my y values going to? Well, if this is the negative side of x, what are the y values going toward if they're pointing up? Positive infinity. If x is going to positive infinity, that's the right side. What are my y values going toward if they're pointing down? Negative. You'll have somewhere there, could there be asymptotes? Yes. Make sure your asymptotes will go to actually a full number, like 2 or 3 or whatever. But this is it. This is all you have to do. This is easy. Okay? So right now, we're not going to play.